So they say there are 4 forces acting on an object given by force A, 40 newtons east, force B, 50 newtons north, force C, 70 newtons west, and force D, 90 newtons south. So they say what is the magnitude of the net force on the object, what is the direction of the force. Well, the first is to be clear about, where we have north, south, east, west, right? So on the plane, we have the north up, we have the south downward, we have the east to the right, we have the west to the left. Okay? So when they give me all these forces, I'm going to get an XY plane like this, and I will put all those forces in the XY plane, in the XY coordinate. So we have the force A that is 40 newtons east, so it's 40 newtons to the right. So this is the force A, and it's just 40 newtons, pointing to the right. Then we have the force B that is 50 newtons north. This will be my force B. And my force B is 50 newtons north. Later, I have a force C that is 70 newtons west. So this is C, 70 newtons west. And then now we have the force D that is 90 newtons south. So force D, there is a 90 newtons south. I don't know if there is a weird sound outside there. No idea what is that. So we have D, there is 90 newtons south. Now, when we have all the forces located on my coordinate system, I will find out the sum of the forces in X, because the resultant force in X, right, will be the sum of all the forces that we have in X. I am adding the forces as vectors. So in X, I have, two vectors that are force A, vector A, plus vector C. Now, I'm just representing, a sum of two vectors. Now, the problem is that now when we go over directions, we can say that R sub X, that is the sum of the forces in X, is the force of 40 Newton that I will put positive, because I will be taking positive all the forces to the right, minus 70 newtons that I will put negative, because I will be taking negative the forces that are to the left. So any force pointing to the right, it would be considered positive. Any force pointing to the left would be considered negative. So I have that R sub X, the resultant force in X, is a force of minus 30 Newton, right? So I can say basically that R sub x as a vector, is a force of 30 newtons, 30.0 newtons left, right? 30.0 newtons left. So this is my resultant force in the direction of the x-axis. Now we're going to do the same in the direction of the y-axis. So we say that R sub y, the resultant force in y, which is the sum of the forces in y, if I make a vector sum, it would be vector b plus vector d. Sorry, vector b plus vector d. Okay? So we have vector d here. So as I said, now we can just make the sum of the forces in y, define the resultant force in y, and then when we try to find this resultant force in y, we get that R sub y is equals the sum of the forces in y. I will be taking the forces pointing up positive, so we say 50.0 newtons. There is B minus 90.0 newtons, which is D. So it would be R sub y equals to minus 40.0 newtons. So as a vector, we can say that R sub y is a force of 40 newtons. The resultant force in y is 40 newtons pointing downwards, right? So there they have the values of R sub y and R sub x. So now what it means that when we put R sub y and R sub x on the rectangular coordinate system, you have that R sub y is 40 newtons downward, while and then this is R sub y, while R sub x is 30 newton left. So I know that the resultant force here, graphically, if I use the method of the parallelogram to add these vectors, the resultant force would be a force like this. And the resultant force would be an angle that I will call zeta from the negative x-axis, or if I want to measure the angle with respect to the positive x-axis, it would be 180 plus zeta. Well, let's find the magnitude of r, and the magnitude of r would be easy because r is basically like a hypotenuse of a right triangle, where R sub x and R sub y are the lefts, right? So we can say that R is the square root of 40.0, well, in this case, R sub x is just, let us just put R sub x, R sub y first. R sub x squared plus R sub y squared. So R would be a square root of 30.0 newtons squared plus 40.0 newtons squared plus 40.0 newtons squared. And when you calculate R, you find the square root and everything, you will get R is equal to 50.0 newtons. So this is the magnitude of R. Now you will calculate the angle. And to calculate the angle theta, you say that theta is the tangent inverse of the opposite side over the adjacent side. So this is the opposite side, R sub y, adjacent side is R sub x. So it's tangent inverse of R sub y over R sub x. You know, so it would be tangent inverse of 40.0 newtons over 30.0 newtons. Of course, the newtons are going to cancel out. You will get the tangent inverse of 4/3. And tangent inverse of 4/3 is going to be 53.13 degrees. So 53.13 degrees is the angle being measured from the negative x-axis to R. Now, if you want to say, well, alpha will be the angle if I measure R from the positive x-axis, alpha would be 180 degrees plus theta. So it would be 180 degrees plus 53.13 degrees. It would be 233.13 degrees. Well, what is going to be alpha? Alpha would be an angle that you would measure like this. You know, from the positive x-axis to R. So that angle alpha, you know, is 233.13 degrees. They say the boat moved through the water with two forces acting on it. One is a 2.0 times 10 to the third newtons forward push by the water on the propellant, and the other is a 1.80 times 10 to the third newtons resistive force due to the water around the boat. So what is the acceleration of the 1 times 10 to the third kilograms boat? If it starts from rest, how far will the boat move in 10 seconds? What will its velocity be at the end of that time? So let us make a diagram. So it's always a good idea to make a kind of diagram, visualize what's going on. So we have the boat here. And on this boat, we have a force. There is a push, right? That is what basically make the boat to move forward. And this force is 2 times 10 to the third newtons. At the same time, we have a resistive force acting on the boat. It's the resistance of the water to the motion of the boat. And this resistive force is like a friction force, right? We call F sub R, resistive force, is 1.80 times 10 to the third newtons. So what we have to understand that in this case there is a net force, or there is an unbalanced force. Just put this in red better. Sorry, in black better. So I have this unbalanced force now. Or net force. There is F minus F sub R. So which is 2.0 times 10 to the third newtons minus 1.80 times 10 to the third. So this would be 0.2 times 10 to the third newtons, which is the same that 2.0 times 10 to the second newtons. So basically, the unbalanced force that we have is 2 times 10 to the second newtons, or 200 newtons. Now, if we want to find the acceleration of the boat, we know that the acceleration to the boat is the net force divided by the mass of the boat. The net force is 2.0 times 10 to the second newtons. And then we have that the mass of the boat is 1.0 times 10 to the third kilograms. So when you perform these calculations, you will get that this is basically 0.2 meters per second square. So this is your acceleration. Divide the net force by the mass of the boat. In the second part of the problem, they say if boat start from rest, how far will the boat move? Right? How far will the boat move in 10 seconds? Now we need to use equations of kinematics. There is one equation of kinematics. There's this one that says that delta x is equal to v sub 0 t plus 1 over 2a t squared. When they say it starts from rest, what that means is that v sub 0 is 0, so we can get rid of this term, and we can say that then delta x, which is going to be the displacement of the boat, will be 1 over 2a t squared. We know a, there is 0.2 meters per second squared, so we can say this is 1 over 2 times 0.2 second squared, so we can say this is 1 over 2 times 0.2 meters per second squared times, you know, the time, which is 10.0 seconds squared. And then when we calculate the time, so how far this boat goes in 10 seconds, you know, at this acceleration starting from rest, we're going to find that it goes 10 meters. So in 10 seconds, it travels basically 10 meters. Now, what is next? The next is to find what is the velocity at the end of these 10 seconds. So what I know the acceleration of the boat, I know the time, and I want to find the final velocity of the boat. So there is another equation of kinematics that relate these variables. That is v final is equals v initial plus at. Acceleration time, we know that v initial is 0 because the boat was initially at rest, right? So we can say that if I want to find the velocity at the end, v sub f is equals to at. So acceleration is 0.2 meters per second squared times the time, that was 10.0 seconds. So this would be basically 2.0 meters per second. So at the end of the 10 seconds, the velocity of the boat would be 2 meters per second in the direction of the force. The displacement of the boat would be 10 meters. And, well, based on the forces that were acting on the mass of the boat, the acceleration of the boat would be 0.2 meters per second. So this one is a very good problem, you know. that combines the second Newton's law also with acceleration and having the equation of kinematics, so displacement, acceleration, velocity. It's an interesting problem, because it's a problem combining not only the Newton's law but also the laws of the kinematics.